give Jose David comments individually. Sorry, I don't want us to go over time today. Chucho, use your voice. Let's hear you.
Good morning. Okay, I want to share some ideas about my research. My research at the beginning the course is the same. There's volatility and growth. Nexus. I am trying to address the problems and the geometry and nonlinearity problem in my field with these three variables. As you remember, I am going to analyze three relationships. This is a traditional relationship, depth and growth. I want to introduce a three variable in this relationship. This variable, when this variable don't appear in the research, generate two problems, endogeneity and nonlinearity. In this case, I want to introduce this variable to solve or address these problems. I am going to show some empirical results from other research trying this relationship, this bivariate relationship. This is my idea. Where if I find significant, statistically economic speaking, relationship between volatility and growth, depth and volatility, and depth and growth, we need to integrate three variables in one research. This is the first empirical results. This is the sample of countries, developing countries. We analyze 79 countries, and you can see the average GDP. GDP is the gross domestic product, crecimiento económico, per capita, and you can see the level of growth in developing countries. High-income countries present 3% of growth rate. The middle income is near to zero, and low income present negative growth rate in this period. Moreover, you can see the volatility of these countries. You can see the high income countries present the lower volatility, and the low income countries present the high volatility. These tables show a negative relationship between the growth and the volatility in these countries. These measures show instability inside these countries and the negative effects of external shocks on the macroeconomic growth. But this correlation is not strong evidence about the relationship between growth and volatility. Then I'm going to show this table. This table presents the similar results, but in this case, you can see the effect of volatility on growth. We have three regressions, and in each of three regressions, you can see negative relationship or negative effect of volatility on growth. The results are robust in this case. What is the conclusion here? The negative relationship is clear between volatility and growth. Yes. The second evidence. The second evidence shows the relationship between depth and volatility. This is the switching model. This is the demand of depth, demand of resource from depth, and this is the supply of resource of debt. These positive coefficients show when the countries face external shocks, high external shocks, need more debt resource. But the international market doesn't wish to give this resource to the country. We have the problem. The countries need more resource and wants more resource, but the international market prefer don't give that the resource. Then the statistical significance of variables show that this relationship is relevant. Then we have two key results. The first results, there are negative relationship between the volatility and growth. And the second result, there are supply-demand issues between volatility and debt. The third relation is related with the debt and growth. You can see here high levels of debt produce a negative growth in developing countries. Here we can see this coefficient is significant, and 1 point of volatility in 1 point in debt produce a reduction in 3% of 0.03% points in GDP growth decrease. Then the third key result, additional to the others, is the negative relationship between debt and growth. So we have here, there are here we need to integrate this relationship in one model. Then if we integrate these relations, we can solve or manage the problems, the key problems, endogeneity and nonlinearity. The endogeneity can disappear as the issue more addressed or more analyzed in the literature. And nonlinearity has a challenge for the researchers in empirical research. In this case, I hope this relationship of these integrated three variables can solve the problem, or in the worst case, reduce these problems.
Okay.
Thank you. Questions?
I like the slides. Yeah, I like the model that you propose in the first, and you always come back the model, and I understand that this was the conclusion at the same time, at the same. For me it was clear, and I think so that with my acceleration about the significance, probably that it's more easy to understand the model, but it's an aggregation.
Yes.
I like the slides.
I also appreciate a lot your report personally, because now I understand in a better way your proposal. Just a little detail, in the last triangle, when you are now showing the results, you can just put the positive or negative relationship, not the both of them, because you have the results now. And in order to clarify what was the result, but it's just a little detail.
The correlation.
Sign of the correlationship, the correlation and after the operations.
Just a suggestion is put the numbers to the slides in order to be more easy to ask something.
Like not like a page number kind of thing?
Yeah.
Something like
Like
this.
for example, slide 5, I have a question.
Yes, it's more easy if you have a question in a specific slides. You put the slides in your question and continue with the presentation. You know, it's come back, more. Now that's a question. It's more easy at this section. Okay, well, one thing is before there are dev route relationship. Is that relationship manage or influence the new relationship that you present as a variable considered in the endogeneity and nonlinearity image? Because I don't know what is the previous relationship that is existence. You begin with that relationship between dev and route, and I don't know if this relationship is the same or is different or it has impact in your final relationship definition. The first one, you have this relationship, and if this relationship has represents something,
Yes.
I like to know if the relationship previous existence in the previous works have some impact or influence in your relationship, or if it's the same or it's completely different.
This relationship is a issue as analyzed by the critical and theoretical literature. The results, some researchers, is that the relationship is null. Certain.
It's no really
Other research say that the relation is positive when the country has a low level of debt. The theoretical analysis says similar results. And other vein of research say that the relationship is negative because when the high level of debt, produce a change in incentives for the macroeconomic growth. When you have high level of debt, your production, your output, go to the lenders, the international markets, and the product of your default don't arrive or don't come your home.
Okay.
In this case, the people don't have incentive to produce more product.
Yes.
There are positive and negative and null relationship.
Okay, and you find it. Thank you. And one suggestion for the table, you say that is for the other table. It's before, but you put the numbers there. You say that the height is the minimum of that, and it's not middle income, it's minimum.
No.
Yes.
It's a negative.
No, in the last one, the standard deviation of the gap. You see that signal that is the minimum in the high income and is the maximum in the low income, and in the middle it's less than the high income.
But the difference is not significant.
Okay, but you have to say, I saw the numbers, I said,
You're so critical, it's amazing.
It's like 50%.
Okay, we have to pass to Jesus. My quick comments as Chucho is going back to his seat and as Jesus is connecting, have to do with language. You guys are very good at the content part, so I'm going to keep my comments focused to the language part. What I notice as a strength in Chucho's presentation style is the suggestion that he made to Maria Carolina. Although sometimes I have a hard time understanding some of the words that you say because of specific sounds or stress patterns, like, and this is a common word that people make a mistake on in this class, analyze, not analyze. Analyze, not analyze, okay? So it's word stress, things like that. Although sometimes I'm like, what did he say? I can interpret the message because of the way he's changing his intonation. So it's like, I can understand this is the contrast, or this is the conclusion, because he either raises his pitch or lowers his pitch. And so that was that's a great success of your presentation style. So even though you have like a couple of pronunciation, word stress, and sound errors that impede my comprehension, I get the message based on the way you're changing your volume and intonation. So that's a strength of your style. Jesus. Let's go on a region of interest journey.
Good morning.
Good morning.
I'm going to talk about a part of my results, my research, related to signal features. To begin, a feature is an information that you can get from a signal. We are working with a metal detector based on pulse induction. Pulse induction is a device that sends a pulse in current to a coil and send an electromagnetic field, and then receive the response of if there is an object near to the coil. We are going to talk about a little bit to context and results and conclusions that we can get. Okay, in 1997 occurred the Ottawa Treaty. It is related to mine ban, to stop producing landmines. Colombia has the mining activities from 1997, and from 1999 accidents were detected using artisan mines. The problem in this moment is the artisan mines, but the artisan mines have wood and PVC and has a low metal content because it has a little bit piece of metals and explosive. In this moment, the algorithms are related to facilitate the detection of landmines and use of 2 or more sensors. Why we are working with metal detector? Because we have to build a dual sensor using metal detector and using a GPR, ground penetrating radar. What were the tests that we made? The first, on the right, remove the object over the coil in a straightforward line, and it was useful to define the calibration parameters to the device. The device is built here, it's not a commercial detector. And we can get, with this kind of test, an evolution of our PI prototype. The second test is related to the scanning area. It is the model that we use, and it has 50 and 50 centimeters approximately, and the height is about 80 centimeters. You can bury the object different heights And with this test, we can get A scan, B scan, and C scan. The evolution of our PI prototype is this: red and red and green. Green is without object, and red is with the object at the center of the column. Next, it was 1.5 years ago. This is 1 year ago. We have a better response in order to get information, the features. And this is the signals obtained, or like Y, when we move the object from left to right. And finally, this is actually our PI detector. We have saturation point. It is important in order to obtain the information about the size of the object. And we have, when we don't have the object near to the coils, we have this response blue. And it is important to discriminate the object in order to the size of the object. Okay, this is the B scan and C scan. This is the surface. This is the signal obtained each point. In each point, and C scan is the area. And this is the sensor. You move the sensor left to right and up to down. And in this, you can move the sensor from left to right or right to left. This is the point that we have tried at Y. In the axis X, we have N points, and the axis Y, we have M points. The object were put near to the center. And this is the B scan obtained the signal without processing. And we can see the difference. Each line at Y, you can see that we can see when the coil is near to the object and then to far to the object. And we can put this in like a video. You can see the effect here and here. We have two periods at Y. And this is the signal with processing, segmented. And we can see the video too. Sorry. Only the effect is better, it's clear. We can get features there. And this is the energy obtained in each point. And this is the principal components obtained from this energy. We see two differences. We have a lower level and high level. In this case, we have the zero. We have here a zero reference, because if you want segmented where the object is here, is difficult than this one. It's more difficult here than this one, because you need put like a threshold. But it's different if the object is a can or is a ball about 25 millimeters diameter. But here you can put a plane and cut this image, this surface, and take where is the object there. Test with a ball, 25 the same energy and principal components. And this is the C scan. And the conclusions. Three main conclusions get. The algorithm design can be implemented in embedded systems because it covers and it shows the shape of the signal. I didn't describe the algorithm, but we have the algorithm working. It is the necessary calibration stage in this device because it's about results. We have calibration stage necessary in order to make the measures better and get the information in the correct way. And the energy results, CS-scan show different levels from different objects, but the principal component results show a level of 0, reference that can be used in order to determine the position of the object. It's better to use the principal component than the energy. And the result shows significant differences between objects with different size, and it's difficult to discriminate different positions of the same object with a pulse induction metal detector. If you put the aluminum can in different position, it's difficult to get information about the orientation. And this is the limitation here in this device. And using time frequency transforms, weighted, for example, will allow us to obtain additional details of the signal features.
All right, we don't have time for questions on this one because Jesus went over time. So, Diego. While Diego's getting set up.
I understood that your device have two signals, GPR and for metal.
No, that device is only
metal. Okay.
That device is only metal detector.
Okay. And the other one is how is the response between a solid material, completely of metal like the ball, and with the can? It is a this composition or solid state or something or shape feature has some response, important response in the signal. It could be if it's more higher or if more longer. You see that the size is with the size of the ball on the signal, but if it's something like that for the composition, or if it's really solid or if it's just a surface.
No.
No.
With a metal detector, it is difficult to obtain because it is related to the eddy currents. The eddy currents occurs on the surface of the object, not into the object. Yeah. Then, if you have an object with a big area of this surface,
Yes.
you can get a better response of our detector.
The compacticity of the
No, you can see that using a GPR,
okay.
ground
The other
penetrating
side.
radar,
Okay.
because it can discriminate between the object with different materials.
Okay. Thank you.
Jesus, it covers all kind of metal products or something, or just the iron.
Aluminum and iron, and this ball was made with carbon steel. And it is the same that in the papers you can find. And this scan is similar to the papers obtained. The problem here is that this research are found with or sponsored by military governments, and you can get a lot of information easy. Yeah. But we can get the CS10. We can see the CS10.